morning, students. Today we're going to work with 15.1 central angles and inscribed angles. I'm first going to do a few definitions. Of course, we must understand the language that we're talking about. So, what is a circle? A circle is all the points equidistant. Doesn't matter which point I take on this circle. Any point on the circle is the same length from the center. The distance from the point to the center, will be equidistant. Equal distances. Okay. All the points will form a circle. A chord. What is a chord? It's a segment, and a segment is just a line with endpoints. So it's going to be any segment line whose endpoint is on a circle. So this will be a chord. It's underlined. And a circle, equidistant, chord, any line, segment with the endpoints on the circle. Diameter. What is a diameter? It is a special chord. And what's special about this one? It contains the center of the circle. That one can be anywhere, but this one must go through the center of the circle. Then we call it a diameter. And an arc, unbroken part of the circle. So here we go on the circle. We're not stopping. Somewhere we're going to end. We have endpoints that's on the circle, and all the points in between is an arc. So this is an arc, and we have a chord. Chord is in the middle of the centers of the circle somewhere. Arc is on the circle. Okay. We have different kind of arcs on the circle. We must move on the circle. A minor arc will be between this point, endpoint, that endpoint. Let me give you the correct English words. The points in an interior of a central angle. So we have a central angle here in the middle, and all the points that will be part of this central angle. Let's go to this side. What is a central angle? The central angle will be the angle formed at the center of the circle, okay? And the inscribed angle will be the angle on the vertex that's on a circle. This one is formed at the center of the circle. So inscribed on the circle, central angle at the center of the circle. So back to this one, when we work with a minor arc, it will be part of this central angle, formed by the central angle. We can measure this minor arc. Okay, this arc, indicating to ourselves it's part of make a little bow, it's part of the circle. The measurement will be exactly the same as the measurement of the angle ACB. ACB. And this angle we will measure in degrees, so this minor arc will also be in degrees. They equal this angle and the minor arc. The major arc will be all the points here on the exterior of this central angle. So this part will be a major arc. How do we calculate the major arcs? A, G, B, look, A, D, B. And how do we get this major arc's measurement? We're going to take 360 degrees, because right around the circle is 360 degrees, and subtract this minor angle, or subtract the angle of this angle at the center. Okay, 360 degrees minus this The angle ACB will be this angle, subtract it, and you will have the measurement of this major arc, also in degrees. A semicircle, it is a special arc, part of a circle. The endpoint must be on the diameter of the circle. Then it is a semicircle. So it's also a part of an arc. It's also an arc, but we have give it a special name. It must be half of the circle because it's lying on the diameter. Adjacent arcs. Here we have an arc with an end point. And then we have another arc. It's making blue. And they are going to share an endpoint. So if they have a common endpoint, the blue and the red arcs will be adjacent arcs. Okay, done the semicircle, adjacent arcs. Intercepted arc. What is an intercepted arc? An intercepted arc is lying on an inscribed angle, the one that's on the circle. Okay. Then we've done that. Now there's two theorems that we're going to work with. The inscribed angle theorem. Inscribed angle. My inscribed angle is this one here, the point D, that's on the circle. And this theorem tells us that this measurement of the angle ADB, that's the inscribed angle's measurement, will be equal to half of the central angle. Now let's write that one in a different color. The central angle is this one, and that is the measurement of ACB. ACB, the red one. So we must remember the central one is the bigger one. You can see that red line is bigger than the inscribed angle blue line. So half of the center angle will give me the smaller angle that's on the circle. Okay, last one here, an inscribed angle of a diameter. And if this is a diameter, you can see it's going through the center. What will be the size of this inscribed angle anywhere? Doesn't matter where I draw that angle on the circumference of the circle. It will always be 90 degrees. Why would that be? How big is my central angle on a straight line? On a straight line, it will be 180 degrees. So the one on the inscribed angle must be half of 180, so we will end up with 90 degrees on the circumference. Okay, we need to know all these words, all these theorems. Take a good look.